What is up, people? How's it going? This is Bharat and welcome back to yet another video with the OpenCV and KivyMD series. We've been nicely progressing along the last three videos looking into multiple different things that are quite possible with OpenCV and integrated into our KivyMD application. For this video, I'm going to be discussing with you guys how you can integrate a face finding. In fact, I'm going to be doing something called as a smile finding application, which is very basic, to be honest, in the OpenCV world. But how do you do it with KivyMD? How do you integrate that with KivyMD? That's what we're going to be finding out in this video. So let's get started. This video is sponsored by Embold.io. Embold.io is a static analysis code tool that helps you fix your bugs much more faster. For this example, I'm going to be running the Embold.io on the tool towards the end of this video and finding all the different bugs that are out there. The tool gives you 8 different metrics that you can make use of if you're managing a very big repository. I would highly recommend you guys to check their first link in the description and make use of their free tier right today. Alright, so this is where we left off in the previous video. We learned about how to integrate OpenCV, we integrated PyTesseract and all of that sort. So if you're jumping for the first time to this video, I would highly recommend you guys to check out the first video from the series where we learned how you can integrate a simple CV2 video capture into the basically a KivyMD application. So for this one, we're going to be using the same template here as well, where we're going to be having a continuous capture of frames and render that as basically a simple video. So we're going to be extending that to do something called as a face finder. So what exactly is face finder? Face finder has been there with OpenCV and machine learning for so long, and it's also evolved over time that it is able to find faces much more accurately than it could do 5 to 6 years ago. So basically for this one, you're going to be doing something called as a face finder slash smile finder, where the application that we have will capture the video, which is going to be real-time video, and identify where the smile is or if the person is smiling or not. You can extend this to do multiple different things, which I'm going to be discussing in the next video, where we'll probably be doing something called as a face swapping, which is a very famous Snapchat filter slash Instagram filter. So we're going to be attempting to do that in the next video, but this is going to be the base for that. So I hope you guys watch till the end. So what we need for that is to basically have something called as a face facade. So face facade is basically where you put your application or you put your image through something called as a Cascade Classifier, and this classifier takes care of identifying or comparing with already available model, with compare that with the current image that it has, or basically the frame that it has, and identifies where the face is basically. And once it identifies the face, then it's very simple to identify where the smile is, right, if the person is smiling or not. So that's what we're going to be attempting to do. So what you need for that, first thing we need is, already we have CV2, so it's the Cascade Classifier is part of CV2. So let's create something called as a self.face facade. Facade, however you want to call it. Facade is going to be basically saying CV2 dot Cascade Classifier. So make sure to pass the Cascade Classifier, and pretty much it. So we have initialized the Cascade Classifier, but we don't have any models that is already there. Either you can train your own model or make use of the models that is already available as part of the CV2 itself. So like I said in the start, this isn't basically like something completely new to OpenCV. I'm not doing something, or I'm not reinventing the wheel itself. Everything's already documented and all of this code is already there. I'm just primarily giving a way to introduce this Cascade Classifier into your KivyMD application, so you can do all sorts of cool things. Alright, so I'm going to be giving the link to the first Cascade Classifier. So basically it is present in the OpenCV repository, which is right here. As you can see, it has har Cascade, which is basically a type of algorithm that runs on the Cascade. So har Cascade has a lot of experiments available. So what we're going to be using is, we're going to be using the Smile Cascade Classifier. So I'm going to be opening the link. You can open it as raw and download it. Basically you go to raw and you have this basically, right? You just save as, and you can save it as whatever you want to. I've already done that, and it's basically present in my repository right now. So make sure to keep it in the repository. This is going to be in my OpenCV Kiwi repository. So just say har Cascade underscore smile .xml. So basically it's right here. So I put it inside my repository right here. So it's right here, right? So frontal face and Cascade smile. So it's basically the file right here. All right, so we have done the har Cascade, we have introduced that, and we also have loaded that into our self.face facade, the variable. Now what is the next step that you want to do? Now if you want to quickly run this application, I just want to show you guys what application we are having at this point of time. What is it saying? All right, I made a small mistake right here. We don't need to have this. So basically, this is how the application is looking at this point of time. Hello. So that's the camera that is actually running right now. So basically, it's running my MacBook camera. So it's picking that up and it's running, and all of those sorts of things are happening. All right, let me move that out for now. Just close it, and we already know that this is the image that is going to be running. Now, what I want to do as part of this is to have this face facade continuously capture. It's already capturing the frames. That's what is happening as part of this logic right here. So this logic right here is capturing videos, sending it as frames, and this frame is being basically read, and it's actually showing that as part of our text. This is what we looked into the first video of this series. Very important if you want to build upon on top of that. All right, so we already have the frame. So what we need now is from the frame we're going to be applying our face facade, and we're going to be finding out, just basically say here, we got to have a simple image grayscale, right? So first things first, always move to a grayscale, so it's very easy to identify. So it's a CVT color, and it's going to be CVT color. We need to have the frame itself, and you're going to be saying it's going to be cv2 dot color bgr to gray. All right, so bgr to gray is present, so make sure to pass it into the buffer. Everything as usual, like you have been doing in the last couple of videos. So luminance is very important. This is where your texture is created from the grayscale and not your bgr or the RGB scale. That's very important. So that's what we're going to be doing right now. Color fmt. All right, great. And if you run this, it will be running it in a grayscale, that we already know. So next thing we're going to do is from the grayscale, you're going to be applying our face facade classifier on top of it. So let's just say self dot face facade dot, you'll just have you'll be detecting multi-scale, and you're gonna say what is the frame or what is the image that you want to run it on, and you're gonna say gray, comma, you'll be now saying what is the input parameter at basically the lowest threshold that I need to detect that is going to have a smile. So if you have it very low, it will have a lot of noise. Unless your images or your videos is completely clean, there is no background data present, it's cool. If there is a lot of background information, like you saw behind me, that's a desk behind me, there's a cupboard behind me, light behind me, all of those things are going to add to the noise. So what you can do instead is to almost have a very tight threshold or very low threshold, and that can eventually find a lot of good things. So I'm going to be keeping it very small, 4.5 to 5. Basically, I'll just keep it as 4.5. We'll see how that works from there. So once we are done with the grayscale, or once you're done with finding out the grayscale, what we need to now do is assign it to a variable. So if you just do this, it will return back a data which is going to be basically like smile. So I'll just call it a smile. This is going to be basically the frame that or image that is going to be with the data of or with an NumPy array, or basically that's going to have the information where exactly in the image is the smile going to be. All right, now it's time to build a very simple rectangle around it. This is also something you frequently see in OpenCV, and I'm just going to do that quickly. So what you do and how you do it is basically say for x comma y comma z comma or width and height, you say in faces. In this example, it's smile, and you will say cv2.rectangle. You will be drawing it on the grayscale, so just say gray comma plus w y plus h, and it's going to have the color 55 0 comma 0 and a thickness of 2. So basically just quickly saying the starting point, the width and height, for what color, and what is the thickness of the rectangle. So this is again something you usually see, you're frequently seeing as part of an OpenCV application. Let's have done the rectangle. We have drawn the rectangle on top of it, and we're also successfully able to now create something called as a Smiley Classifier. I'll just run it up and we'll see how it works. And again, one more important point on this is that it's highly dependent on what CPU you have. Yes, the CPU might not play a big role if you have a very good CPU. Let's say you have a GPU also in your system, it might not play a very different, there might not be a lot of difference. But let's say that you have a smaller system, or you have a very less CPU that is going to be able to do all this classification for you, it might affect the performance, and that's something that you need to keep in your mind. So it might not be the same in your system as well. So you got to definitely play around with your thresholds. So let's run this first of all to see what is happening, and you'll have a much better and cleaner understanding. All right, so this is what I told. Now see, you can see my smile being detected, but also it is detecting something here, something that is something here. So I'm just going to now, okay. Now if you see this one right here is also being detected as a smile, but it's not a smile, right? So that means my thresholds are totally off, and that is because it's inputting a lot of noise into my image or my frame as well. So I'm going to increase my threshold by 6 or by 0.2, and I'm going to try running this again. All right, so after playing around with the numbers and stuff, I have actually found out what is fit for my system right now. So I increased the threshold to 4.9, sorry, and the upper threshold to 6, and even then it still has a lot of false positives at this point of time. It's continuously finding things that is not even a smile. So if you see a lot of things here, so it's up to us to clean this up. But first things first, let's attempt where my face is. So it's still not finding my smile or anything of that sort in my face region right now. So I'm going to look at the camera. I'm going to look at the camera and try to smile. So if you see that, it's able to find out the smile that is actually in my, like it's finding the smile that is on my face and things like that. Now if you want to make it even more accurate, that's where your face recognition, or basically like hard cascade face model, comes into picture. So you quickly replace that. Again, you can find that in the GitHub repository that I showed. It's pretty much right here. So you can have the frontal face. There's a lot of things available. Basically, what you're going to be using is the hard cascade frontal face default, which is going to be the model that we're going to be training our cascade classifier into, and then using that. So basically, say hard cascade smile default, or what, frontal face default, right? So frontal face. Don't have to change anything, just have to go down here and probably change the input parameters, probably 1.5 to 4. Let's try this out first of all. I don't want to love a lot of things right here. Awesome. Now if you see, I'll pull this into the picture. It's not finding my face, right? I turn back, it's able to find my face. Not my face, face, not my face, face. So that's pretty much how you do things, and very simple to do, right? You don't have to understand or know a lot of things about what is hard cascade classifier, what is a cascade classifier, anything of that sort. In the hindsight, it's important to know how these things work, but not the only way to work with this. So machine learning is simply a base layer for us to play around with and keep on adding. We need to build stuff, and this is how you build stuff. And I would highly recommend you guys to use this in your application and let me know, because for this one next up, we're going to be looking into the Embold static IO analysis tool, run our code on a static analysis and check if there is any mistakes that were happening. So I'll quickly go ahead and submit this to the GitHub link that's present in the description below, and we'll run our static analysis tool on top of it and find out what we are missing. Let's go. Alright guys, so I've made changes to the application, and I've also pushed it to the GitHub link right here. We saw this about in the previous video, so make sure to check that out. And what I'm going to do now is just sign into Embold, and obviously I've already signed in and all of those things are completed. So I'll be taken into the GitHub. I will be signing with the GitHub, and it will automatically connect and it will show me my package. So I'm going to be quickly waiting for that. All right, so this is the package, and we did the scan in the previous video for this. What I've changed now in this video is I've made, or removed, I should say, changes. I've removed files from the changes. So what I'm going to do is go to my repositories. So you go back to your add repositories, and you can just click on, this is basically the GitHub link that I have. I've put it in the description. You can check it out. All right, so this is going to be the package I'm going to be scanning. I'm going to be going down here, click on add repositories, Embold, and it will start scanning. So basically there are very little files right now compared to the previous video. So wait for it to scan, wait for the scan to complete, and I'll show you guys how easy and very useful it is to catch all the bugs, and also gives you multiple metrics that you can use it for your repository. Alright guys, so the scanning is completed and it has found out about 27 different issues. We'll quickly go inside and see what these are. So basically, if you see, most of these issues are coming from the pi-n or the vn itself, and I'm not mainly worried about it. So this is going to be from the smilefinder.py. So we'll click on it, because I don't really know what this attribute define outside in it means. So it says very clearly that I have something like this, being defined outside the init. So I should probably have it as image frame outside the init. So this is very important. And when you do all this, when you fix all of this, make sure that it will also include a lot of different metrics as well. So I'll quickly show that as well, so that it's easy for us to see what happens. So if you go down here, it's finding 8 different metrics. So it says efficiency, the efficiency is about 75. Okay, functional wise it's 100, which is very good. Maintainability is 26, primarily because there's only 3 or 4 files in my repository itself, so it doesn't make much sense to see that. Security is also very important, right? It says very, very good. Reliability, conceptual integrity, portability, and analyzability. Okay, that's not what I'm worried about. I'm worried about the efficiency, and I'm also worried about the usability. So usability is very, very, very low, because it says that there are 6 issues affecting this KPI. So you can go inside and click on the 6 issues, and it shows you what are the different things that it's actually affecting that. So it's very low probably here. Nothing is of major sort, which I need to definitely fix. So again, I have a lot of different metrics and data within my hand to fix my repository, and it's very, very useful if you are actually going to be maintaining a repository where multiple people are pushing code inside. All you need to do is just scan it once a while and make sure to fix all of this, and it will make sure that your package is much more secure and also good. All right, so one more important thing which I want to show is how easy it is to find duplication in code. Now, duplication in code is something which most of us do not actually talk about. I specifically pushed the code from main.py into SmileFinder and photofilter.py to show this specific portion only. It's actually able to catch 100%. It says that 100% of the code here is actually being duplicated from these 2 files. So it's actually, that's the reason why it's giving an overall rating of minus 0.36. So if you're somebody who's actually going to be managing a huge repository, like I said, and multiple files are going to be there, right? Maybe 120, 200 different files, and you can easily find and catch all of these duplication in code and modularize it so that you can easily maintain it in the future. I am in love with this, basically this tool, and I'm going to be definitely using it. One important thing is it's completely free. You can use it for any public repositories for free, and up to 20,000 lines of code for a private repository as well. That's an amazing thing, right? So make sure to check the first link in the description, and you'll be taken to the page where you can use it and sign up for free today. All right, so that's pretty much it. Let's go back and summarize this video. All right, guys, so that's it for this video. Hope you guys did like it. We looked into how to understand or use the hard Cascade Classifier, which is basically an OpenCV classifier method, and we also did do 2 things. One we did was the Smile Finder as well as the Face Finder. So in the next video, we're going to be building on this face classifier and do something called as a face swap that you usually see in your Instagram and your Snapchat, right? So we'll be trying to do a face swap between 2 different people, and let's try how that works out. I'll meet you guys in the next video. Until then, Bharat, peace out, have a super awesome day.